Welcome again to this class. This session, you're also going to solve a problem testing on projectiles. And the problem reads, a particle is projected from a point O with speed 35 meters per second at an angle of elevation of 30 degrees. The particle moves freely under gravity. So find the length of time for which the particle is 15 meters or more above point O. Now, it is always good manners to draw a sketch representing the information given in the question before you start breaking the question into subbits to enable you to solve it with ease. So, solution. So let's draw the sketch. So this is the vertical motion, vertical and then horizontal. Let this be the motion. And then let this be the speed of projection, call it U. And in this case, U is 35 meters per second. And then, so this point is O. And let's call this point where it reaches, it hits the ground again to be A. So we're interested in finding the length of time for which the particle is 15 meters or more above the ground. So we can draw an arbitrary line, say this, such that this distance is 15 meters. And as you can see from this one here, we expect to have two time intervals at this point here, and then this other point here. So it's like this is T1, this one is T2. So to find the interval, the length of time for which the particle is 15 meters or more, so mean that this is the region. So that time would be simply given by T2 minus T1. So that would be the length of time for which the particle will be 15 meters or more above this starting point O. So remember, this is still 15 meters. So as usual, we resolve the velocity projections both in the horizontal and the vertical directions. So resolving, projection of velocity both horizontally and vertically. We have, so horizontal, as usual, is given by ux, and then remember this angle here is alpha, and for this case we have been given as 30. So it's u cos alpha, which will be 30. The u is 35, so 35 cos 30. at 5 cosine of 30 degrees. And then vertical is uy equals to u sine alpha, which is at 5 sine of 30 degrees. And then this at 5 sine cosine of 30 is giving 35 root 3 over 2 and say meters per second. This is the one that 5 sine of 30 is 35 over 2. So simply 17.5 meters per second. And then we have S equals to UT plus a half. We know that this is a equation of linear motion, relating speed, initial speed, time, and distance. So for our case, we have our distance is 15. Our uy is 17.5, GSM of just u. Our t is the unknown. Our acceleration, because we are taking this, remember, acceleration is g when you're moving downward, but it is negative g when you're going up. So a is the same as negative g, which is negative 9.8. So therefore, putting in this formula, we have 15 equals to u, which is 17.5 times time, minus a half times a, which is 9.8 times t squared. This implies 17.5 t. This will be 4.9 t squared. And then we can form a quadratic equation. Take every term to the left. So I have 4.9 t squared minus 17.5 t plus 15 equals to 0. So let's use quadratic formula, minus b plus or minus square root of b squared minus 4ac divided by 2a. So remember, in this case, our a is 4.9, our b is minus 17.5, our c is 15. So t will be, so minus b will be positive 17.5 plus or minus square root of minus 17.5 squared is 306.25 minus 4 times a, which is 4.9, times c, which is 15, is 294, divided by 2a, that's 9.8. So t will be 17.5 plus or minus 306.25 minus 294, square root of answer 3.5 over 9.8. So T1 would be 17.5 minus 3.5 over 9.8, and T2 would be given by 17.5 plus 3.5 over 9.8. So T1 10 over 7, T2 15 over 7. So the length of time is given by T is T2 minus T1, which would be 15 over 7 minus 10 over 7, which is 5 over 7 seconds. Therefore, the length of time for which the particle is 15 meters or more, above the starting point O is that 5 divided by 7, which is 0.7, is 5 over 7 seconds, which is equals to 0.7142857 seconds. So that's how we solve that problem. Thank you.